So in this next unit, we're going to start by looking at comparing a quantitative variable in 3 or more groups. This is really just an extension of what we got done doing in the previous module, where we discussed independent versus paired samples. There, we were just comparing a quantitative variable in 2 groups. So now we're extending the idea to 3 or more groups. First of all, the name of this is called ANOVA, or which stands for Analysis of Variance. Now, in the previous module, we discussed again comparing 2 groups, and there we had to first figure out if they were paired or independent samples. Inside this unit, we will only be talking about situations where we're comparing 3 or more independent populations or groups. Thus, we will not have to worry about how to do dependent ones if we have 3 or more groups. Please note you can have 3 or more groups that are dependent. We will just not be investigating how to analyze that data in our class. To understand how this is going to work, we're going to start by just investigating an example and doing some descriptive statistics of what we've already seen in previous modules. So here we're interested in seeing how changing one's diet or exercise regimen has an impact on weight loss. So we have 57 participants, which we randomly assigned equally to one of the following groups. We have one group that did no change in diet or exercise, sometimes referred to as a control group. We have a group that increased their exercise by 2 hours a week, or we had a group that decreased their calories by 250 a day. This was done over a 6-week period, and the amount of weight loss is recorded. So first, thinking about if I have a person in front of me, what information do I need to know about this person? Well, one thing that I'm obviously going to be recording here is how much weight they lost. So whatever their weight loss is. So if I had 2, for example, that person would have lost 2 pounds. So this variable is going to be quantitative. What else I have to know about each person is which group were they in. Were they in the no change group? Were they in the increasing exercise group? Or were they in the decreasing calories group? So I need to know which of those diet or weight or exercise or no change groups they were in. So this variable here is going to be categorical. So do notice I still only have 2 variables, one that's quantitative and one that's categorical. Just now my categorical option here, there are 3 options they could fall into for that categorical variable. So we're going to first start by just looking at some graphs of our data as well as getting some numerical summaries of our data. You have this in your note handout, but we're just going to do it in StatCrunch here as well. So I've provided the data set here for you, so you can do the StatCrunch here as I'm doing it as well. So it's just this weight loss data set that I gave you, and we're going to load that in here. Now I've given you lots of different types of graphs, so I'm going to show you how I got all of those. So first I'm just going to do the histograms that you see. So I'm going to control click so I can click them all. And then I wanted to make sure I could easily compare them, so I want them all to have that same x-axis because it'll allow me to see them more easily. And then to have it look the way that I did, I changed this rows per page to be 3. That way when I hit compute, I have all 3 histograms here for us to be able to look at. The other thing I did was change how wide each of my bars were so that we could compare them as well. So let's say I did 2.5 for your note, so that's what I will use here as well. So here are those graphs that you have. So here is the nothing group, here is the exercise group, and here is the diet group. To make the scale match what we have in the handout, I just started them each at -5. So now they will look exactly the same. They're in a slightly different order. The nothing and diet have kind of flipped places here, but that's not a big deal. So there's those 3 graphs. Then to get the box plots, just went to graph, box plot. Again, kind of control clicked to get them all. To have them in the same order, if I do diet, then exercise, then nothing. That'll give you in the same order there. I unchecked this box about identifying outliers and then just hit compute. So here is the same graph that you have there in your notes. And then finally, I did a dot plot for each of them. The reason why some people might like a dot plot is because it allows them to see each individual person. I'm going to reorder those just so they match your output here as well. So that way you can see each of the individual people and sort of see where they fall here on our weight loss variable. So that's just how I got all of those graphs. Then here on the next page at the top, you see the summary statistics that gave us our means, our sample size, standard deviation, all of that. Just a reminder of how we get that information is we go to Stat, Summary Statistics. I choose column since that's how my data is organized. Again, just control click for all of them. And then down here, I just clicked to get the ones I wanted. So my mean, my sample size, my standard deviation. And then I got that 5-number summary that's used to create our box plot. And then hit compute. So there are those numbers I gave you. As you can see from your note handout, I rounded the mean and standard deviation to 3 decimal places for us, but otherwise the numbers are the same. So first, that's just looking at StatCrunch, but now let's actually look at what we might be interested in. So I'll even just kind of start by looking at the dot plot here, as well as our summary statistics. So what I would probably want to know is, let's suppose that I'm trying to lose weight. What should I do to lose the most weight? Well, if I look at doing nothing, there are some people who actually gained weight. If they got a negative weight loss, that would mean they gained weight. But we do have people that still lost some weight, even by doing nothing differently. In our diet group, I have one person who did actually gain weight, but most everybody did actually lose weight since they're all above 0. So it does kind of look like maybe dieting is better than nothing, but notice there are still people up here who lost more weight than the people down here. But finally, looking at the exercise group here, all of them actually lost weight. None of them fell below 0. So all of those seem pretty big. But again, there's people down here in the diet group that lost more weight than some people in the exercise group. So one thing that's about dot plots and these graphs that we look at is it tells us what individuals look like. So by looking at these, it looks like probably maybe exercising is doing the best. It doesn't guarantee that you're going to do the best, though, by exercising as an individual, right? Because some people lost more weight by dieting than by exercising. And so I might want to just look at these trends, say, okay, if I did this, what would I expect to see? So what we're going to do is we're going to go through those 4 characteristics, shape, outlier, center, and standard deviation, and interpret them just as when we did originally with our descriptive quantitative statistics. So let's first talk through our no change group. So looking at that graph, so that'd be this dot plot, or this top histogram here, how would we describe the shape of this graph? Well, it definitely looks unimodal, but a big question would be if it's symmetric or if it's possibly skewed, and if it's skewed, which way. Now, if you were going to say it was skewed, you would probably say that it's skewed left. But let's go back and look at our mean and median here to see how different they really are. So the mean is a little bit lower than the median, but you might actually be able to make the argument that those are relatively close, and so you might say, well, that graph is relatively symmetric. Again, not perfect, but not bad. Are there any outliers? Not really. We have our mean and median to be able to interpret those values, and then we'll have to do the math to do that standard deviation calculation here. So let's do that for our no change group. So when looking at how much weight was lost, by those who did nothing different, the shape of our data is unimodal and pretty symmetric. With no outliers. The mean weight loss was 0 pounds, which isn't very shocking that if you did nothing differently, on average, you would lose 0 pounds. And so I do apologize. I was looking at the diet numbers up here instead of the nothing numbers. So if we look at those, we do get zeros for both the mean and the median, helping confirm to us that this is actually a symmetric graph. So I do apologize. I was looking at the wrong numbers there. So with our half, or 50% of people losing, now you could say more than 0 pounds, you could say at least some weight. Different ways you could phrase this here, especially with it being 0. Finally, we want to do our standard deviation idea. So we start at our mean, which is 0. We go out our standard deviation in either direction here, which was 2. So here we get between -2 and +2. So then we could say the typical person here fell between gaining 2 pounds and losing 2 pounds. Remember, we were recording the weight loss, so this -2 are the people that gained 2 pounds, and here actually the +2 would be those that lost 2 pounds. Now these are the same 4 characteristics we've been doing for a long time, so try the diet group and exercise group on your own, and you can see if you agree with me. Alright, so seeing if we agree here on the diet group. So again, go back and looking at the graph here. So here is our diet graph down here. This one does actually look pretty symmetric and unimodal. no kind of point sticking out like a sore thumb, so really no outliers there. Then our mean was the 2.816 pounds. The median was 3, so half of them lost at least 3 pounds. And then doing our typical value, so our mean and our standard deviation are used to get the 1.19 and the 4.442 pounds. Now for the exercise group. So finally looking at the exercise group. Here, from looking at the graph, it definitely looks much more skewed. However, if I look at the mean and median again, so 6.95 versus 7, those are actually very, very close, giving me actually a pretty strong argument that I could say that they were pretty symmetric as well. Again, nothing really kind of standing out like a sore thumb here, so really no outliers. So again, so I describe my shape as still being unimodal and pretty symmetric, again, mainly getting the symmetric here from the mean and median. Again, no real outliers on this one. This time our mean weight loss was almost 7 pounds, and half of them lost at least 7 pounds. Our typical value between 3.883 and 10.011. Again, getting that from looking at our mean, which was the 6.947, and then going out our standard deviation in either direction, which was 3.064 when I rounded to 3 decimal places here, giving me that 3.883 and 10.011. So really up to this point we haven't done anything new. But what we have is that we have these 3 groups that we're trying to compare. Is there something I would recommend to people and say, well, this is what you should do to lose weight based upon this data that I got? So here's all these different ways of looking at our data. Looking at our box plots, right, that kind of gives us also an idea. Kind of looking at this box, that exercise, the entire box is actually above this box, and this box is entirely above that box, right? So we're kind of seeing how different these values are. There is definitely some overlapping going on, but are they different enough for me to say, hey, this is the best thing you should do to lose weight? Or saying, there's not really any differences between these 2 methods, so you could choose either of those. Or are there no differences and there's really no difference at all on what you do to lose weight? It's not going to really change things. So what I would like to actually end up doing is saying, well, are there any differences in these 3 groups? And if so, what are they? So what I've got to do first is actually do some hypothesis testing to find out which ones of these are different and how. So that's what we're going to start talking about, is how are we going to test that? We'll discuss that in the next video.